Welcome to Mathematics Online Lecture Series by Professor K.V. Narasimhan, Vector Calculus. So, in the earlier classes, we discussed about the vector differentiation. Now onwards, we will discuss about vector integration. Now, this is the first lecture on vector integration. So, first we will discuss about line integrals. Now, what is line integral? Then how to find the line integral? Then we will discuss the few problems based on line integrals and applications. Few applications. Okay. First, I will explain what is line integration. Okay. Line integral. So, integration along a line or a curve is called line integration. Now, how? We will discuss. Suppose if you take a curve, okay, I will take one curve. Okay. First, I will take a curve. Okay, I will take in this direction, which is in three-dimensional geometry. Okay. So, the first point is A, second point is B, which is in three-dimensional geometry. Okay. Now, first we recall what is the vector point function. Vector point function. What is the vector point function? For different values of x, y, z, if the function of x, y, z becomes a vector, j plus f3k x, y, z into k. So, for different values of x, y, z, you will get the different vectors. So, this vector is called vector point function. Suppose if you take a curve which is in three-dimensional geometry, okay, it has infinite number of points. I will take few points with red color. Okay, this is the first point. I will take few points. This is the first, another point, another point, another point, another point, another point. Okay, we have infinite number of points. I will take few points. So, at this point, so you will get some order triple. Suppose, for example, this point is 1, 1, 1. So, initial point is 1, 1, 1. I will take. Suppose the corresponding point is 1, 1, 1. Last point is 2, 2, 2. Just for understanding. For different values also, if you put x equals to 1, y equals to 1, z equals to 1, you will get a vector. In the similar way, another point is 2, 2, 2, you will get another vector. So, suppose if you take n points, first point is P0, this is P1, this is P2, this is P3, P4, P5, P6, P7, and up to last value is some Pn. Actually, we have infinite number of points. Now, I will take n points. Now, suppose if you put the corresponding point on this vector, you will get some vector. I will call it as R1, just for understanding. If you put P1 in this function, you will get R2, R3. In the similar way, you will get Rn. Now, if you observe, the length of this part, this arc, P0 to P1 is some say delta 1. Delta 1 equals to, what is delta R1? Delta R1 equals to P1 minus P2. Now, length of the second part is P2, P1. Length of the third part is P3, P2. So if you find all the lengths, and this is corresponding function value f of r. Just I will explain f of, okay, I will take differently, f of P0, f of P1, f of P2, just for understanding, f of Pn. Now multiplying this one and length, f of P, some I will take some vector P0. Instead of P0 I will take any other vector between these two, okay, into delta R1 plus P1 into delta R2 plus and so on, f of some Pn into delta Rn. Now this summation is simply, I will write it as sigma f of some Pi delta Ri, I varies from 1 to n. Now this is sum. If you observe, this summation is look like integral a to b f of x dx. So same procedure, now a curve is given from point A to B, and different slices and length and this function value. Add all the values, you will get this summation. In the similar way, if n is infinity, the number of points is not finite, infinity is infinite points, then this summation Pi into delta Ri, this summation is called integral. Now first point is a to b, integral a to b f of r into f of r dot dr. This integral is called line integration. Okay, this is called line integration. Okay, I will explain in detail. Let us consider a continuous vector function. This is continuous vector function, like previously I discussed in one example, which is defined at each point of the curve in the space. Divide C into n parts, already we discussed, A and B, P0, P1, P2 and Pn. Let us their positions vectors be R0, R1, R2 and so on, Rn, position vectors. Okay. Now the summation S equals to sigma I is 1 to n f of ui into delta r. So ui be the any position vector between this vector, this arc length. Now delta ri equals to ri minus 1. This summation, if n tends to infinity, this summation is called integral f dot dr. Integral f of r dot dr. This is called line integration. Line integral of f of r. Okay. Now what about the circulation? If the curve is closed, in the previous example, the curve is not closed, just a to b, some curve. If the curve is closed, then the line integral f dot dr is called circulation. If C is a closed curve, then this integral is called circulation. Circulation is nothing but integral f dot dr along the closed curve. See, it can be written as this one, f dot dr. So, and read as integral f dot dr along the closed curve C or circulation C. Now, one more very important applications of line integral. Suppose we have, just for understanding, suppose we have a curve. So this is a particle. I will take another color. Suppose we have, this is first point A, this is point B. We have one particle at this first point. Suppose if you apply some force, force is a vector, then what happens? It moves along this curve. Suppose if the curve is in this form, so it is moving on this curve only. Suppose if it is circular curve, it moves along circular curve only. Suppose if you apply some force on the particle, then what happens? This particle moves on this curve. Okay. From one point to another point, what is the work done by this force? What is the work done formula? Work done formula equals to force into displacement. Force into displacement. Force into displacement. From point A to B, so divide into not only from a small arc, work done on the small arc. So entire curve from A to B, A is the first point, B is the last point. Then this is called the work. So what is the formula? Work done equals to integral A to B F dot dr. Force into displacement at a small arc. Now if you add all the works from this arc to this arc, total, then you will get the total work done. Now this is the formula for finding the work done. Okay. Now we will discuss about line integral. Integration along a line or a curve is called line integration. Okay. First I will explain a problem. Then how to solve this problem. Okay, very easy. Concept is very easy. Try to understand. Now solution. If f equals to 3xyi minus y square j. Evaluate integral f dot dr along the curve C, where C is the curve in the xy plane. Only in xy plane, no z component is included. What is the curve here? Y equals to 2x square. From the point, suppose this is the parabola. I will take this one. This is look like. Now from point R00 to some point 1, 2. This is the first point, this is the final point. Okay. Then find the integral f dot dr along this curve only, this part only, from A to B only. Then how to find the value? Okay, I will explain one by one. Here we will integrate integral f dot dr. Okay, then what is the procedure? Okay, I will explain. We know that, just try to understand. Very easy. R bar equal position vector xi plus yj. Here z component is not required, there is no k term. So if there is any k component, then take zk also. Dr equals to dx I plus dy, just derivate. So now what about f dot dr? Dot product with f. 3xy dx plus not plus y minus y square into dy. Okay, fine. This is f dot dr. Okay, this is the important result. First result is this one, f dot dr. I will take another color because this one is important. Okay. Now coming to first part is completed. F dot dr is okay, but f dot dr in terms of x and y. Now what is the path given that y equals to 2x square. Now what about its derivative? Dy equals to 4x dx. Substituting the above results in f dot dr. Then we get what happened. F dot dr equals to, first term is 3 into x into y equals to 2x square. So transformed into single variable. Now y square equals to 4x power 4 dy equals to 4x dx. Okay, y square equals to 4x power 4 and dy equals to 4x dx. Now simplification. 6x cube minus 16x power 5 dx. So what is this? Integral f dot dr. Okay. Now integral f dot dr along the curve C equals to, f dot dr is entirely in terms of x, 16x power 5 dx. Now what about the x limits? If we observe the points, what is the initial point? Point is 0, 0 to 1, 2. Point is 0, 0 to 1, 2. X coordinate is 0, 0 to 1 only. X is 0 to 1. Okay, fine. First integrate with respect to x. Integrate with respect to x. 6x power 4 by 4 minus 16x power 6 by 6. 0 to 1. Okay. Now substitute the limits. 3 by 2 minus 8 by 3. First, if you put x equals to 1, then if you put x equals to 0, 0. 9 minus 16 by 6. 9 minus 16 by 6 minus 7 by 6. Okay. Now this is the solution. Integral f dot dr along the closed curve equals to minus 7 by 6 is the answer. Okay, I will repeat again. In this problem, just I will explain the only one problem. In the next class, we will discuss more problems. If f equals to 3xyi minus y square j, evaluate integral f dot dr, where c is a curve in xy plane, y equals to 2x square from the point 0, 0 to 1, 2. F equals to 3xy minus y square I. Now we know that r bar equals to xi plus yj. Dr equals to dxi plus dyj. Now f dot dr equals to 3xy dx minus y square dy. Okay, but the given curve is y equals to 2x square, dy equals to 4x dx. Now substitute all these values in f dot dr. F dot dr equals to 3 into x into y equals to 2x square dx minus y square is 4x power 4 into dy equals to dy value is 2x dx, 4x dx. Now after simplifying, 6x cube minus 16x power 5 dx is the common term. Now integrating f dot dr, integral 0 to 1, 6x cube minus 16x power 5 dx. Now integral x cube equals to x power 4 by 4, x power integral x power 5. Just we are using the formula integral x power n dx. So x power n plus 1 by n plus 1, only simple formula. Don't worry, just we are using very simple formula, integral x power n. So x cube integration is x power 4 by 4, x power 5 integration is x power 6 by 6. Now limit 0 to 1. Put x equals to 1. Now this is 6 by 4, that is 3 by 2, this is 8 by 3. If you put x equals to 0, this is 0, this is 0. LCM is 6. Now 3 3s are 9, minus 8 6s are 8 2s are 16, minus 7 by 5 is the answer. Minus 7 by 6 is the answer. Okay. So just try it in the similar way. Just I will give one question to you just for understanding. Similar procedure, f is given and y equals to x cube from the point 1 1 to 2 comma 8. Just simply first find out r bar then f dot dr. Now y equals to x cube. Now differentiate dy equals to 3x square dx. Now just integrate, then substitute all these things in f dot dr. Then finally integrate. Now some terms are there. So everything is converted into the x variable is 1 to 2. Just integrate with respect to x, you will get the solution. Now take it as homework problem. Otherwise, I will explain in the next lecture. Okay, meet again. Thank you. Thank you very much.